Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2018 Physics Paper 1 Higher Tier. Question number 5, which is on the topic of electricity. Complete the sentence, choose answers from the box. The current from an ohmic conductor is directly proportional to what across the component. Now, in an ohmic conductor, the current is directly proportional to the potential difference, provided that the watt remains the constant. The temperature should remain constant. Question 5.2, figure 7 shows a current potential difference graph for a filament lamp. Explain how the resistance of a filament lamp changes as the potential difference across it increases. So what they're asking is to explain the resistance. Now the graph is actually showing potential difference across current. Right? So here they're asking actually the resistance as the potential difference increases. Now you have to link potential difference to resistance. Now you have to think about this equation, V equals IR. Now here, as the potential difference increases, the current is steadily increasing, and then it's actually the rate of increase is actually becoming less. Now if you rearrange this equation, actually let me just explain to you in a different way, explain how the resistance. Now the question you should be asking is, what is happening to the current? Well, as the potential difference increases, the current is increasing, right? You're providing more energy, which is understandable. So the current or the rate of flow of charge actually does increase. But why does it eventually slow down? What's happening? How is that linked to the resistance? Now, the only reason that the rate of change of current or the gradient is becoming less here is because the resistance is increasing. If the resistance increases, the current will actually slow down. Eventually, the current will remain the same while the potential difference increases. Now, main reason for that is because the Y is actually, the filament lamp is getting hot. So let's look at a typical answer. The current increases when the potential difference increases. That's 1 mark, which causes the temperature of the filament to increase. So the resistance increases. So you're mentioning about the resistance eventually, but you're linking it to the temperature and the current for the 3 marks. Question 5.3. Many householders are replacing their filament lamps with LED lamps, which are more energy efficient. What does more energy efficient mean? More energy efficient means less energy is actually wasted, or a higher proportion of the energy is actually being converted to useful energy. So, a higher proportion or percentage of the total power or energy input is transferred usefully transferred. A light dependent resistor, which is this component, the LDR. So the LDR is used to turn on an outside lamp when it gets dark. Part of the circuit is shown, so you have a fixed resistor, the LDR, which the resistance can be affected by the light that is falling in. The 12-volt power supply. The light intensity decreases. What happens to the potential difference across the LDR and the current in the LDR? Now, if the light intensity decreases, the potential difference would increase. Now, if the potential difference increases, what happens to the current? Then the current decreases. What is the resistance of the LDR when the potential difference across it is 4 volts? Now, give a reason for your answer. So you need to state the resistance and the reason. Now, what they're saying here is the resistance of the LD. Calculate the resistance when the potential difference is 4 volts. So if this is 4 volts here, so if the PD across this LDR is 4 volts, if you connect a voltmeter there, if it reads 4 volts, that means the rest of the potential difference out of the 12 volts, it should be 8 volts across this. Now, the potential difference splits in the same ratio as the resistance as well. So this is 1/3 of the power supply, and that's 2/3. Now, if 2/3 is 2000, 1/3 is going to be just 1000 ohms. So the answer is 1000. And the reason is the potential difference is shared in the same proportion to the resistance. Question 5.6. Calculate the current through the LDR when the resistance of the LDR is 5000. Give your answer to two significant figures, which generally carries a mark. So calculate the current. So using V equals IR as the equation, V equals IR, we know that the potential difference is 4. One second. Sorry, that's not 4 volts. Let me get rid of that. Because if I go back to the circuit, this is a series circuit. So what they're saying is the resistance in the LDR is 5000. So if the resistance in the LDR is 5000 ohms, it's a series circuit. So the total resistance is going to be 7000. And the current through the LDR and the fixed resistor is going to be the same. So that's the total potential difference. So I could 12 volt equals the current in the circuit multiplied by the total resistance in the circuit, which is 7000. So I equals 12 divided by 7000. That gives me, let's see, 12 divided by 7000, 0.0017, 0.0017 reoccurring. So 0.0017 would be the answer. That brings us to the end of question number 5. I will see you in question number 6.